Hey everyone, we're going to get started here in just a second. We're going to give the stragglers a chance to get in here and get settled. So,
Unmuted.
Brian, you seem
yes,
to be muted. I apologize.
sorry about that. All right, now we're going to get started.
Perfect.
So, thank you all for attending. I've learned how to use my mute button here, so that'll be a plus for the rest of the meeting. My name is Brian Fields. I'm a solutions architect with Macrofab, helping out customers, get their designs built out into reality. So, background is in contract manufacturing, variety of different industries, everything from oil and gas, downhole tools to complex backplane boards. Worked at a contract manufacturer for a few years, and then worked for a oil and gas OEM, designing and building our own products as well as products for others. So, next. So, some of the things we're going to talk about today, we're going to talk about the reasons your electronics development team can't deliver on time. It's a problem that occurs for a lot of different people for a lot of different reasons. So hopefully we're going to be able to arm you with some tips and tricks and best practices to alleviate some of that pain and hopefully deliver on time in the future. Quick agenda overview. We're going to talk about the PCBA product development lifecycle. These are kind of iron rules of the universe that have to be followed whether you like it or not. So you should attempt to embrace them if you can. Talk about how our bills of materials are limiting design options and limiting our timeline options in today's kind of complex marketplace environment. We're talking about how data integration can help you guys make real-time decisions. And then we're going to talk about goal alignment a little bit and then some key takeaways. Next. This is very true. So warnings warning deadlines are much closer than they appear. So in the engineering services world, the joke is always, oh yeah, it'll be ready in 2 weeks, right? So people 2-week you to death. Don't think to yourself that, oh, I've got time, I'll get to that next, right? Like you can always accomplish a project, under budget and under time. It happens rarely, but that should be the goal, right? So next. Yeah, and so the reason those projects typically go over is that your team hasn't committed to the PCBA product development lifecycle, right? So we're going to go through a couple of those different stages and talk about them a little bit, and then talk about the way that these different stages can impact the life cycle, right? The life cycle of your product development. So very first thing we're going to talk about, electrical validation testing. This is usually when your electrical engineer comes to you and says, hey, got the schematic done, I've got the basic layout done, but there's some stuff I want to test. I'm not quite sure about some, I'm not quite sure about some impedance matched pairs. I'm not sure about some resistor values. I want to poke around with it. I want to play around with it and see how it performs in real life. We see people come to us all the time and they say, hey, I got a design and I want to order 5. Can I order 5? Absolutely. The answer is, absolutely no problem. Run it through the platform and get you 5 prototype boards. Because one of the things that we routinely see, and seems to be true kind of across the board, is there's always a next generation product. There's always going to be improvements. There's always going to be a way to make it better or faster or more reliable. So getting that early prototype out of the way, just as early as you possibly can, is going to be a good step to put you down a pathway for success. So one of the things that can be really helpful here at this stage is to ensure you're building with good quality components, right? So if you, I hate to use idioms, but like garbage in, garbage out, right? So if you've got poor quality materials coming in, you've got stuff you bought off, AliExpress, and then you built on your desk, and you get a certain result from that, you don't know if that's a result because it's the unique way you did it. You don't know if that's a repeatable result. You don't know if that's a result of like a potentially mislabeled part or something like that. And so having really good quality control for your materials when you are validating the electrical design is really, really important. So, next. Okay, so design validation testing. So almost always, PCBs are going to be part of a greater system. And so the more complexity you add to a system, the greater the chance that something's going to need to be improved or is going to fail or it's going to give a less than ideal result, right? So as soon as you've got, a working board, we're pretty sure that we don't have to make the board bigger. We're pretty sure we've got a processor picked out. We've got base functionality working. The board's, walking, talking, doing what it's supposed to do. Typically that's going to let the firmware people go ahead and start and be off to the races and develop against that processor and with those peripherals. And so this is kind of the point at which you would want to stop and say, okay, well, we're going to put it into a box. We're going to put it into an enclosure. It goes in something. It goes in plastics. If I know I don't have to make it any bigger, let's go ahead and validate this design, right? This is where we see people set up a test line or a benchtop manufacturing scenario where they say, okay, well, if I screw this board into this plastic, what happens? Does it break it? Does it give me the aesthetics I want? Do the LEDs line up with the light pipes, right? So being able to not to drive out as much variability early in this process as you can is crucial for not having surprises at the end, right? So one of the things we talk about with these stages is exit criteria, right? And so how do I know which stage I'm in? Well, you go back and look at these exit criteria. Exit criteria for this one is you have high confidence that problems affecting mass production on yields are you've already solved them, or you think it might be an issue and you have a good solve, you have a good fix for it already, right? Things like, well, you can just pick whatever glue you want to use is not a recipe for success, right? You've validated the materials you're going to use for fit, form, and function in your application, and okay, it's not the Gorilla Glue I'm buying at Home Depot. I've chosen Dow Corning RTB 3145 as the adhesive for this because of properties X, Y, and Z, right? It's driving out that variability and making sure you're providing your contract manufacturer good documentation at this stage is going to set you up for success. So next. So product validation testing. Your ideal design gets tested to make sure it will work at scale, right? What you can build on your bench and say, oh, I built 10 of them and it only took our technician 1 day, right, to get all that done, but it really was faster than that, right? Well, you want to make sure that, when you go to order, 10,000 of something, that you're not going to have significant issues, right? There's going to be DFM feedback, design for manufacturer feedback, right? Like, well, what takes a technician, a minute to line up and insert into its housing, if that could be improved and you can get that time down to 10 seconds, you'll realize significant gains when you start having, thousands of units produced, right? So working with your contract manufacturer to understand like where the low-hanging fruit is on design for manufacture, what things can and cannot be changed. If there are testing or programming requirements, working with them to ensure that all of those kinks are worked out so that when you go to mass production, which is the next step here, you're not saying, well, I know we want a tester, but I don't know what we want it to do or what we want it to test. A lot of these steps can be done in parallel, right? So obviously you can't really truly skip steps. I think there's a Gantt chart here we'll look at in a minute. But you can be developing a test protocol from day one. You can be developing good documentation and good bills of material and good mechanical assembly documentation from day one, so that when you get to these stages, you're not like, oh no, I've got 50 documents to write. And so that's engineering's least favorite thing to do, is to compile documentation and write documentation. People want to create and they want to solve fun problems and we work on new stuff. And so saying like, hey, type this Word document tends to be kind of a chore that gets put off. So thinking about ways to get those things done early on and drive that variability out of the process will help you in the long run. Next. So mass production, right? I've never seen anyone come to me and say, hey, Brian, we have a product that's ready for mass production, and that be true. Like that is never once happened. And that's just because there are so many things that go into this stage of the life cycle that people are completely unaware of, right? Like, okay, you can order, yeah, you got custom plastics made for the housing. That's great. How long are those molds going to last? Are they soft molds or are they hard molds? They have different lifetimes, right? Different life cycles. Things like that, where yeah, we got some initial prototypes made, and yeah, we worked with like a local house and they put them together and they lost money on the deal, but we're not going to really change anything. Then we think we're ready to order 10,000. If you haven't done your homework and gone through those other steps in the process, you're in for a world of hurt, right? And what you're in for is going in and placing a big order and you're not ready for it. And some contract manufacturers will say, hey, I've seen people get fired as customers before. You come in, you say, yeah, we're going to have all the documentation ready to go, right? When the day comes and it's not there, you only get so many tries at bat before they kick you back to the curb and say, we have other customers that have complete documentation packages and those guys are ready to build, whereas you are not. So it's something to consider. It's something to work with your contract manufacturer very closely on and really ask for that hard feedback of like, okay, what do we need to be successful? And what are you guys going to fire us for, right? If we come in and we start changing the processor after we've already purchased all the components because the team found some non-ideality, like what's going to happen? It's going to be bad. So working through that variability early on is really a great way to set yourself up for success. So next.
Brian, we actually have a question.
Yeah, absolutely.
As the product team works through the EVT, DVT, PVT builds, how do you handle deadlines? How can teams speed up production without creating new problems down the road if there's a must-hit ship date?
Everyone loves a line in the sand, right? So the secret here, in my opinion, is to do as much stuff in parallel as you can, right? Even if it's just getting familiar with it, right? Like a lot of times firmware teams won't want to develop on the not final design of the board. It's unfortunate, but if you run those things purely in serial, you're going to really stretch out your timeline. It's in a perfect world, that's what we do. but just getting in there and starting that, that firmware development early, even if it's on a Gen 0 version of the board, can be very impactful. And then doing other, what most people would call kind of like secondary processes to the actual development, quality plan, logistics, sourcing, vendor selection, documentation, those type things. Like when you build Gen 0 of a board, when you go all the way back to EVT and you build those first 20 just because I want to poke around and turn them on and make sure they light up and see if they let the smoke out, like you should have a good bill of materials for that. You should be able to show, hey, all the way from version Rev A all the way to Rev M, I've got good bills of material, right? That's just good housekeeping. And then having a good concrete quality plan with that as well can really cut down on the time. Because what you don't want to do is you don't want to wind up at mass production and have no quality or testing plan. And then some poor soul is trying to remember all the ways the boards failed 6 to 9 months ago, and they're trying to compile that in one document instead of having a living document that you've been updating every single time, and you have a quality plan for each version of these boards. So it's not fun, but that's how you cut down on that timeline. It's a good question. You go on to the next slide here. Yeah, so this is that Gantt chart, right? So you can kind of see you've got build, test, and iterate or revise blocks put in here. So absolutely, right? Like so the EVT, you've got an iterate and design phase even before that, where you're deciding what those prototype boards are going to look like. We've got some traditional things that we see happening in here as well. So there's gonna be a critical problem. Oh, that processor you planned on using has a lead time of 52 weeks. Okay, well, how are you going to solve that, right? Because 52, getting the processor in 52 weeks is a non-starter. It's not going to work for the business. So figuring out what those problems are as early as possible and driving that variability out of this process is going to be key, right? You've got that XVT. That's an acronym we didn't touch on in here, but that's that external or designing for X validation test, where we're you're having to go back a step and redo some things because we're unclear on what actually went wrong, or the problem we're trying to fix, or stuff just didn't meet design criteria. Sometimes you get a swing and a miss, right? One of the other things we can do to cut down on some of these timelines this mentions is, hard tooling and soft tooling, going back to the logistics, right? And driving out as much variability there. Like, oh, well, we'll just get molds from the plastics vendor. Have you confirmed that? What is their mold lead time? How much does it cost? What happens if you need to make a change? What is the mold lifetime? If you're shooting just like, I don't know, like polycarbonate or nylon or something, your molds may last way longer than if you're shooting like glass-filled ABS. So those are just things to consider, right? And ways that you can cut down, like you want to know all that information as early as possible, so that when you get to the last steps, you're solving those important problems only the problems that are left, right? And not, oh, I have 50 deliverables to get over the finish line the last 2 weeks, right? So next slide here. Yeah, so this is really the big takeaway from this piece. We see people just straight up not commit to having entry and exit criteria for these different pieces to the puzzle. So even if you are an amazing product development team, and you've got all these processes, and you got all these superstar engineers, that's great. Even if you spend one whole day in each individual step in the chain, you're still going through these steps. But if you go straight from EVT to mass production, the universe is going to kick you in the teeth, and it's not going to be fun. So one of the other things that can kind of happen here is a lot of times the project manager or product owner and the actual engineers will be a little misaligned, right? So I think we're going to talk about that here in a second, but keeping a good alignment and, whether it be weekly or daily or monthly syncs with the team to ensure that the direction the project is heading is the direction the business wants it to head, right? Like the functionality of the device at the end of the day is not, well, wouldn't it be cool if it did this? It's the functionality that meets the needs of the business. So next. Yeah, so one of the things we see really often is bills of material problem. So I don't want to beat a dead horse, but everybody knows that parts are hard to get here at the moment. Lead times through the roof. There's silicon shortages, and if there's ever any additional geopolitical instability, it could really get bad. So what we see more advanced and frankly more successful customers doing is realizing that we're going to have to select alternates, right? We're going to have to make changes to the bill of materials if we want to be successful. So seen this a lot, especially when you have like pin compatible ICs. If that IC comes in multiple different footprint sizes, including those footprints just right on the board can be really helpful. This lets you drop in essentially the same silicon with different footprint sizes right onto the board. Keep your FCC certification if that applies, or keep your UL if that applies. It's the same part, it's just in a different package size. I also see this happen a lot with ICs that have built-in things like memory or RAM or EEPROM, where it's like, oh, you only may need the 128 version, and that's $10. But the 256 version is $15, and the 512 version is $20. So keeping that flexibility and just understanding that, like, yeah, it's an extra $5, and that's kind of hard to swallow sometimes, but it lets you build product. And so when you're at those design stages, going ahead and putting that into the bill of material, so your contract manufacturer doesn't have to run into dead ends and then come back with hey, I need 43 alternates to build this board. You can build that in and say, hey, if these are true one-to-one alternates, you can select from column A, B, or C. They'll all work, and you're going to have way fewer problems to solve down the road. One of the other things we see people do here, and this is maybe a even more advanced technique, is we see multi-path bill of materials. Now this will really increase your engineering cost, but it's going to let you build material. It's going to let you build product, right? Especially when you're constrained on material. So what this is like if I've got TI DSP or an ST micro processor that both give me similar functionality, I know that the passives and the other stuff that go with that on the board are going to have to change if I swap those two out. Obviously, they're different Gerbers, different copper. But I've got 2 or sometimes 3 different fully functional bills of material, and I can say, okay, well, if I can get all, and whichever one of those gets parts first is the one we build, provided it gives similar functionality for the device and for the end users, right? So it'll increase your engineering spend, but all that engineering spend doesn't do any good if you can't build product. So it's something to consider. One of the other things we see people doing is rolling back functionality, essentially functionality, right? And so if you can't have all 27 features, well, which ones are stop dead? Which ones could you potentially live without? And if you've got some that you could live without, that's a hard choice to have to make. But if it's a difference between deploying a product to the field that gets 80 or 90% of that customer functionality at maybe a reduced price or something, versus deploying nothing and saying, oh, it'll be 52 weeks. Hard choices to have to make, but sometimes that's the unfortunate reality of the world we're in. So next.
We've actually had a couple of questions come in while you were.
I'm sorry, I was not watching.
So during periods of component shortages, the risk of purchasing counterfeit electronics increases considerably. What does Macrofab do to safeguard that stuff? How do we work with our partners in order to keep that from happening?
Yeah, so counterfeit parts is a very real concern. As parts got more expensive, it became way more profitable for some of these I guess counterfeit houses to make counterfeit parts, right? So if a if an IC used to be $1 from analog devices, $5 from analog devices, it wasn't worth it to counterfeit that. Well, now that it's selling on the secondary market for, I don't know, $100, well, suddenly that might be a good idea for us to try to counterfeit that part. A lot of times the counterfeits are really good. They'll kind of work. So we realize that exists, right? And so when we do have to source from secondary markets, we're an ERAI member, and we participate in that organization to help drive that counterfeit market kind of out of this secondary market. And so all of those parts are always tested at third-party test houses, and all money's held in escrow and all sorts of stuff. So they've got systems with our strategic sourcing group in place to ensure that stuff doesn't make it into the legitimate supply chain. So it's a good question. Thanks.
And one more. Can you explain a little more why dual footprint layouts are good for when you're planning for FCC certifications?
Yes, it's good because you're not going to have to. So when you get that FCC certification, let's pretend it's your Bluetooth module, right? Well, if that module comes in multiple footprint sizes, that you're not going to have to go back and recertify if you use a different size silicon, right? So if that footprint comes in multiple form factors, it lets you choose between those multiple form factors. Now I effectively have, well, maybe the smallest one isn't available, but the medium sized one is. The functionality can be identical, and you can still retain some of those certifications. Go to the next slide. There we go. Yeah, so talking about how having the data and having that integrated into your design process can really help you here. Knowing the PPV and understanding how the actual supply chain gets sourced, or excuse me, the bill of materials gets sourced through the supply chain can be very impactful, right? Like even very early on, getting a quote, right? Like doing something like dropping it into the Macrofab platform, getting a quote and saying, oh, okay, I should probably not use these things. These are 52 weeks, or, oh man, the price for that is way higher than it was 2 years ago when I designed a similar board, can be really helpful knowledge. And that, I mean, that's just a couple clicks away. It doesn't cost me anything, right? One of the other things is that you'll see factory windows open and close. And so, depending on when a factory has, availability or what that capacity looks like at a factory will determine really kind of their desire to work with you and how much they're willing to like give you a spot on the line, right? Like if you are a 5,000 unit a year customer and you go to a contract manufacturer that is at 90% capacity building for General Motors, well, like they're probably not going to give you the time of day if they are at capacity and they are, they don't need anything, they don't need any more work. If you go to somebody who has more capacity, you're gonna potentially get much more can be hand holding, customer service, development help, things of that nature, right? So understanding where the contract manufacturer is as far as capacity goes, and then where they can potentially fit you in. Sometimes people are going to say, oh, well, I have a 1 million unit job, but that's going to end in March. I can fit you in March. That might not work for your timeline, because if your files are ready if you're ready for mass production in December, taking that additional delay is not advantageous, right? So bottom line here is work with your CM to get like a strategic rollout plan there, so that you can have you don't incur additional delays for factory availability. Yeah, so I hit on this a little bit earlier. Having those team syncs, not always the most fun part of the job. Nobody likes looking at their calendar and seeing that you have like 13 different team stand-ups to do. But having everybody on the same page of paper is crucial and important, right? Because scope creep is real, and the number one creeper of the scope is the engineering team. I can't tell you how many times I've heard someone say, well, wouldn't it be cool if, and like the thing you're saying is cool, and it would be cool if we did that. That is not in the design spec. It's not in the scope of work. And like you're talking about a complete side quest here that's gonna, potentially cost more money and do these other things. So ensuring that the technical goals and the business goals are aligned is absolutely crucial. And then all of that is rolled up to stakeholders, right? Whether they be internal or external, um, is extremely important. So next. Yeah, so these are some of the key takeaways here. It's easy to miss deadlines. You got to be flexible and get and drive as much variability out of the process as early on as you can, and document. I used to tell people, great's the enemy of good enough, right? So, or don't let good enough be the enemy of great. Excuse me. So even if that documentation is just a Word document, put it together, mark it Rev A, and send it. And iterate that on that in the future and drive that variability out over time, and don't wind up at the last minute with 8 blank documents you have to create from memory, because it's not going to happen. Consider additional strategies that'll get you where you need to be from a business perspective. Even if those are hard conversations to have, even if they do result in increased spend or decreased capabilities, you got to ship product. So having those kind of in your back pocket and already potentially having those conversations early can help alleviate some of those feelings around those. And the more data you have about your bill of materials, your production schedule, your CM, and their capabilities, the better off you're going to be, right? Because eventually you're going to have to go get all this stuff made somewhere. You're not going to build all these things on the desktop at your house. So really working with that contract manufacturer as early as possible is a huge benefit. I see people tell me pretty frequently, they're like, well, I'm not to the point where I can talk to you guys yet. I guess you can. Like it's an enormous benefit to just go through the quoting process, to just have trained people in the industry look at it and go, hey, what is this? Or okay, no, that'll work. And having, giving those opinions are free. And so like going through that process it'll be painful, because everybody's going to want to drive out, all that variability. They're going to want to get every single thing defined, but it's going to give you an additional set of eyes, it'll give you more data, and it'll let you make more informed decisions. So next, I think we're ready for questions.
Yes. Does anybody have any questions for Brian? Any more detail that we've chatted about? Oh, here we go. Do you know of any resources that would help kickstart multiple footprints, and perhaps what small groups of footprints will work together?
So my background is not in layout and design, it's in manufacturing. But what I've seen people do is when you've got a particular family or class of, let's say, processor picked out, going and looking at those spec sheets and then seeing, like, if you're on like DigiKey or Mauser or something, like seeing if that comes in other footprints, right? Or deleting off the second half of the part number and saying, okay, at the base part number, what is this, right? It's like, oh, well, it's a TI processor that comes in these 3 or 4 footprints at the family level. Well, if they're footprint compatible and they all have the same silicon inside them and they don't have a difference in functionality, a lot of times they'll just come in different footprints. One of the other things I've seen people do is for passives. If you really have to, you can place things on pad sizes or shapes that they're not meant to be placed on. Don't tell anyone I told you that. But so you can potentially like, oh well, if the world is out of let's say 0603 resistors, like we can probably get away with placing a 0804 in that spot if we have to, right? Without spinning the boards and doing things like that. So like getting creative and working with your contract manufacturer to understand their capabilities can be really helpful.
We have one more. Is there a foolproof way to know how much a build is going to cost right now?
Well, I hesitate to say yes with the caveat of foolproof in there, but because everything's going to be an estimate, unfortunately. And so, you know, you can get really accurate estimates. What I would say is just get your contract manufacturer to give you a quote. If it's just a board, feel free to drop it into the MacroFab platform. That's, you know, unless you deliberately engage a human being with MacroFab, you can use that platform until you're blue in the face. And if you want to upload all your designs and say, okay, well, it's telling me that I can get 90% of the parts, and it'll cost this much at this lead time, and then it gives you that information about which things aren't available. You can select alternates right there. But that'll give you a real quote. And so if you've got a box build or you've got a product, that adds a little bit more complexity because, you know, you show up and you're like, okay, well, how much is it to build this thing? Well, there's a lot that goes into this. And so that'll involve a little bit more like, you know, one-on-one quoting and interaction to get a quote. But even when you get a quote, I mean, there's going to be some estimations that go into that. So it's never going to be quite perfect.
Are there any other questions? Anyone? Thanks for your time today, Brian. That was really great. Thanks for everyone for attending. We have a couple of upcoming webinars. Brian, on September 7th, will be doing with Autodesk circuit board layer stack up and manufacturing. And MacroFab will have another webinar in October that will cover Chinese New Year and how to prepare. I hope everyone keeps an eye out for the post webinar. We'll send you out the slide deck and any information, and then also keep an eye out for a treat in your inbox. So thanks everyone. Hope you have a good day. Thank you. Bye.